Hey everyone, it's Mrs. George, and this lesson or this video is going to be on the periodic table of elements, how to read a periodic table. So this is the one that I've posted onto Google Classroom. Now, if you notice, first of all, for most of us, it's very confusing. You're probably sitting there looking at it like, oh my God, what are all these colors? What's going on? Well, we're gonna become best friends with the periodic table, and we're going to really learn how to read it. Now, if we were in school, ideally we would have started this unit a lot earlier, back in April actually, so we would have been best friends with the periodic table by now. But you know, it is what it is. So I guess we just gotta do with what we have, all right? So no need to stress out or whatever. It's just we're just gonna do the best with what we have, all right? So let's get started. What do you notice when you first look at the periodic table, right? You see, I want to bring your attention to, let's look at the first one right here, hydrogen, okay? Looking at through some of your exit ticket answers, and I noticed that most of you, yes, have said that hydrogen is the first element in the periodic table, okay? Number one, you see that one here. Now, do you notice there are other ones here, okay? Now, we'll get to that later, but really, the periodic table is read left to right. So 1, 2. 2, helium being the second element. 3, lithium. 4, beryllium. Whoop, whoop, whoop. We skip over to 5, boron. 6, carbon. 7, nitrogen, oxygen, fluorine, neon, sodium, magnesium. Whoop, we're going to skip again. 13, aluminum, silicon. Okay, so we're going to go up to argon. Now you notice something different happens over here, period 4, okay? And I say period 4 here because this is what the rows going across are, periods. And you'll notice that, oh, wow, look, I've got these whole rows that are filled in, but up here, there's this big old gap, right? So we'll learn a little bit more about that later on. So I just want to go back to this first box here. How do I read a periodic table? So any element, right? How do I know what the symbol is? It's indicated by the usually 1 or 2 letter abbreviation of it. H is for hydrogen, right? And you always know that it's one element because it's a capital letter by itself, or if it's a 2-letter symbol, it's a capital letter plus a lowercase letter. So for the example of H2O, and even if I didn't have the 2 there, right? Let's just say, for example, you would know that those are 2 different elements because H is a capital H, O for oxygen, capital O, right? Now take a look at helium, number 2, He. That is one element. What if I have He and F together in a chemical formula, HEF? How would I know that those are 2 different elements? Well, I would use my periodic table because I'm still starting off. I'm still trying to learn how to read these elements. I would see that the capital H, lowercase e, O, F is a capital letter. So I know that's one trick that I can use. But then, like, we're starting off, so I would always suggest please use your periodic table while we are practicing, okay? So the chemical symbol is indicated by a capital letter. It's usually 1 letter or it's 2 letters. So if it's 2 letters, it's going to be a capital letter plus a lowercase letter. On top of it is the atomic number. That's basically the order of the elements. It's order. It goes in numerical order. Go 1, 2, 3, 4, 5, 6, 7, 8, all the way till this one goes to 103. But we have more than that. They're saying that we know that there's more than 118 elements, but so yes, depending on. So atomic number is this on the top, the number on the top of the box. Your symbol is your capital letter. Remember, it's either 1 capital letter or 2 letters, but one will be capital, the other will be lowercase. The name of the element, you will always see the name underneath the symbol. And it says weight here, and this is why I want to use a different periodic table, because weight is not correct. It's actually supposed to be atomic mass. And you know what? I am going to use another periodic table. I'm going to give you guys another table to use because I don't like the fact that it's using weight. Weight is wrong. Don't say weight. When we're talking about chemistry, we don't want to use weight. It's atomic mass. With these elements, we're talking about the atomic mass of that element, okay? So I can have one atom of hydrogen, symbol H, atomic number 1. The name, I would spell it out, hydrogen, atomic mass of 1.008, okay? I move on to number 2, helium, atomic number 2. Symbol, capital H, lowercase e. Name, helium, atomic mass, 4.0026. And for our purpose, 6th grade chemistry, you know, we can just say atomic mass 4, right? We can round to the nearest tenth, I would say, 10th, right? Or even a whole number, I'll be okay with that. For all extents and purposes, we're going to be dealing with the whole number, so we would just say 4, okay? Let's practice some more. Atomic number 3. What element is that? Can you name the symbol? Can you tell me the symbol? If you said capital L, lowercase I, you are correct. The name, lithium. Atomic mass, 6.94. I would round this up to 7 when you see what I'm working with. We're going to round to the nearest whole number, right? Can we do the next one together? Or can you try it on your own? What is the atomic number for the next element? If you said 4, you are correct. How about the symbol? Capital B, lowercase e. What's the name? Beryllium. Atomic mass, 9. Let's move on. Next element in the periodic table. Atomic number is 5. Good. I'm saying good to myself, but I'm saying good because I'm pretty sure you're following along with me, right? Symbol, capital B. Name, boron. Weight. Sorry, not weight. Atomic mass, because I'm going to round to the nearest whole number, 11. Can we do the next one? Atomic number, 6. Symbol, capital C. Name, carbon. Atomic mass, I'm going to round to the nearest whole number, 12. All right, I'm going to pause here because I think at this point, I hope you get the idea of it. That's just how to read the periodic table. All right, so I can even like ask you, and if you were in classes, exactly how I would practice it with you. Okay, class, find the element with the atomic number 18, and you would go and look for the little box of element. Which one is 18? Ah, right here. What's the symbol? Capital A, lowercase r. What's the name of that element? Argon. What's the atomic mass? You would round it up to the nearest whole number, 40. All right. One more for good luck. Let's see. Can you find or tell me the element with the atomic number of 29? I would look through the little boxes, finding 29. Oh, I see it right here, 29. What's the atomic symbol, or what's the element symbol? Capital C, lowercase u. The name of that element is copper. And I'm going to round up the atomic mass to 64. right? So that is how we are reading periodic table of elements. One more important thing to note. You see how it's divided into metals, metalloids, and non-metals, and this is actually color coded. So we're going across in rows, going across left to right, something called periods. There are 7 periods of the periodic table of elements. Hydrogen and helium are the only elements in period 1, all right? You can't sit there and stick lithium in period 1. Nope. Lithium is in which period? Look at the number right here on the left-hand side, all the way to the left. Like it's not even part of it's not part of the little boxes. 2, all right? So 2, second period goes all the way across. The elements in the second period are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Let's try period 3 going across. What are the elements in period 3? Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. How about period 4? I'm not going to go ahead and name all of these, but all the atomic numbers 19 all the way to 36 are all elements that are part of period 4. Elements in period 5 are elements from atomic number 37 all the way to 54. Period 6, pay attention now, things get a little funky. Period 6, you've got atomic numbers 55 and 56. What else? You have 57 to 71. Whoa, there's a gap here, but no, look, 57 to 71 is over here, part of the lanthanide series. 57 to 71, down here. That is part of period 6. Continue. The elements with atomic number 72 to 86 are also part of period 6. And the last period, elements 87 and 88, as well as 89 to 103 here, see? Actinide series, as well as 104 to 118. Oh, I don't know why I said earlier. You only see 103. Okay, yes. All right, to 118. Cool beans? So that's how you read across periods. Now, what are these numbers up here at the top? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Those are groups or the families. Groups or families are the rows or the columns, going up and down. So remember, the periods of the periodic table of elements is the rows going across left to right, and there are 7 periods. There are actually 18 groups or families, and the groups or families are the columns of elements going up and down. And you will see as we learn more about the periodic table, they are actually grouped in such a way because they are a family. The elements in group 1, that's hydrogen, lithium, sodium, I'm going straight down, potassium, rubidium, cesium, and francium. Hey, guess what? They have similar qualities. They have similar characteristics. They're like your own family. You share similar traits with your family. Group 2, family 2. I'm going from beryllium, I'm going straight down. Magnesium, calcium, strontium, barium, radium. They share similar characteristics. There's similarities between them. That's why they're grouped together. Groups 3 to 12, this middle chunk of the periodic table here, are called the transition metals. And they are grouped accordingly because they're metals, right? But then also because they are very similar. They have some qualities that are similar. Group 13, what are those? What are those? Boron, aluminum, gallium, indium, thallium, neodymium, right? These are group 13 grouped together because, hey, again, similar qualities. You guessed it. You can say the same thing from group 14, that's going straight down from carbon, group 15 straight down from nitrogen, group 16 straight down from oxygen, group 17 fluorine and everything underneath fluorine, and then lastly 18 helium and all the way down that column. And group 18 you'll learn later are the noble gases. They are the most stable gases. They're the most stable elements. All right. And we'll learn more about that later. Okay. So I hope that sort of kind of made sense. I know it was a lot. We'll definitely practice. In fact, I'm going to have you guys practice right now. Just looking at the periodic table, finding the atomic number, finding the symbol, finding the name, and I'm actually going to post another periodic table so it says atomic mass on it because I don't want anyone getting confused. And I'm going to see if I can get it where the numbers are already rounded up for you. I doubt it, but I'll see if I can find a Kids Bop version. All right. Please practice.